And then what about the 1 volt? Okay, this is current. Current ka unit ampere and charge ka unit coulomb divided by time seconds. Okay, what about the voltage? Volt. Okay, the work done with respect to charge. Okay, so what is the unit of work? Joule. Okay, charges coulomb 1 volt. Okay, if they ask describe 1 volt, describe 1 ampere, describe 1 ohm. 1 ohm is the unit of resistor. Okay, so this kind of questions you may get. So you have to read everything. Charge is nothing but we can say as the number of electrons. So we can rewrite this formula as I equal to Ne by T. So all the formulas in this chapter are interlinked. Okay, no need to mug up any formulas. So no need to mug up any formulas. All the formulas are interlinked. And then what we want to see. First of all, the foundation class, how it would be now. I will explain you the topic. Then, so for you, it is a revision. Okay, because already it has been covered in your syllabus. For them, it is new. I will explain you. Okay, then we can write the game. We manage this or whatever like this. Okay. If you feel difficult to understand, ask me. I will clear you. So now we are going to see about the Ohm's law. Ohm's law where we are applicable, it is implemented where we implementing Ohm's law.
Usually in the resistors.
Usually in the resistors. Okay. So what is Ohm's law? V equal to I. When you draw the graph with V and I, you will get the linear way. So this graph will denote the resistance. If you are getting the graph in this manner, it is not ohmic resistor. This is ohmic resistor. Understand? When you draw the graph with the value of voltage and current, if you get the graph, if it is in a linear way, it is ohmic resistor. Non-linear way, it is a non-ohmic resistor. And other thing, we are going to see about the resistor. What is resistor?
Resistor is basically an obstruction in the flow of current.
Yes, it is the process of the resistor. What is resistance? Resistor is a component. Okay, it's a very minute component. Each and every resistor having unique number. Okay, in order to find the value of the resistor, we can see the color bands in the resistor. How actually it looks now? It looks very minute ceramic. Okay, having the two terminals. With the color coding of the band, we can find out the value of this resistor. Okay, see, we can have the value like 1 ohm to 1 kilo ohm, 100 kilo ohm, like 200 kilo ohm. We are having many values of the resistor. Okay, by seeing the color coding, we can find the value of the resistor. Resistor is a component. Okay. See, another thing, Resistor is used to resist the flow of current. Okay. Wherever we are using, imagine I'm using the LED bulb for my project. Okay. But I have the source, it is like 20 volt, it is passing through the load. Load is nothing but the bulb which I am having. But it is 20 volt. But LED is what? It having the capacity to withstand the 5 volt only, isn't it? Beyond the 5 volt, if you give now, that the LED will burst out. Okay. In order to obstruct the flow of current, we are attaching the what? Resistor. Okay. For that purpose, we are using the resistor. What is resistance?
Obstruction in the flow.
Yeah. How much capacity it can obstruct the flow of current. Okay. Understand? Now, what is resistivity or specific resistance? It's about the material which we are using. Okay. You may get a question like if you are using one conductor is made up of metal called copper, another conductor is made up of aluminum. Find the resistivity. So each and every material have a unique number. You don't need to mark up any value. If they are asking in the numerator, they will provide the value of the specific resistance of the material. You have to substitute the values. Okay. So sometimes they give you the value, then you can substitute the value and find it, isn't it? And in another question, if you are using the same material like a copper, what is the specific resistance? What would you answer? If I am having the two conductors made up of copper, what is the specific resistance?
The resistance which is provided by the wire is obstruction of the face by the electrons because of the molecule.
Okay. I am saying I am using two conductor which is made up of the copper. Find the specific resistance. How will you find it? You can, they're asking you to compare the resistance. Compare and say me in ratio like that. 1 is to 1 because we are using the same product. Okay. So it about the material which we are using. Then, so what are the factors affecting the resistance? Actually, that's a formula. Resistance is equal to specific resistance and length of the conductor, area of the cross section of the conductor. This is specific resistance. Okay. What is length of the conductor? I am taking this is a conductor. This is the length of the conductor. Okay. Area of the cross section is this. They give you like radius. Okay. Find the circumference of this and get the answer. Okay. You have to substitute that value and substitute in this formula and get the answer. Okay. So, what are the factors affect the resistance? Resistivity, length, and area of the cross section. The Ohm's law, when it is applicable, when the temperature is constant, then only the Ohm's law will be applicable. Okay, so then you have to include temperature also. Okay, understand? Now we are going to see about the EMF, terminal voltage drop. Okay, you see battery having two terminals. Okay, what is the purpose of battery? Okay, so the chemical energy converted to electrical energy, isn't it? Okay, so in this battery, so EMF nothing but. So you people know about open circuit and closed circuit. Switch. If you take any switch now, okay, Now, now the switch is open condition. Okay, closed condition now it will be in this manner. The current getting passed. Okay. See, this is the way. Okay. Here you be here in your home. Okay. You want to come from home to UT. When the road is connected, then only you can come, isn't it? If road is not connected, you can't come to UT, isn't it? So same way, the electrons will fall from how the current flows from higher potential to the lower potential, isn't it? So when charges passes from one point to other, it should travel. When it is closed only, it is positive, isn't it? So same thing. If you take the torch, we are having the battery. Okay, sources inside the battery also. Battery is nothing but charges it having. In a torch also we are having these switches, isn't it? On and off motion. When it turned on, it is closed position, then only the charges will come, then the bulb will glow, isn't it? Same process. When it turned on, so when it is closed, also the charges passes from one point to other. Other thing, when it is open, when it is not passing also, you can add the difference between the two terminals, negative terminals and positive terminals. Okay, so the combination of open circuit as well as a closed circuit is what here. Understand? So when two terminals is there, positive and negative, the difference between the volt between the two terminals, we can get some value, isn't it? That volt, along with that, when it is closed circuit, it passes from other to other end, isn't it? So combination of open circuit and as well as open circuit and closed circuit, how much volt we are getting? It is EMF. When it is closed, we are getting the terminal voltage. Voltage drop is nothing but it reducing the voltage, it passing in the current, it is voltage drop. Voltage drop is nothing but when the voltage getting reduced, it passes through the current. It is determined by the voltage drop. You understand the difference? Now we are going to see about the resistor. Whenever you draw in the circuit now, you have to draw the voltmeter which is parallel to the resistor. Okay, always resistor. When you are drawing any resistor, voltmeter should connect it parallelly. Okay, then series now we should connect ammeter. Ammeter is what? Ammeter is what?
A device measuring the amount of current.
Yes. Then another instrument also we can determine the current. Galvanometer. Galvanometer is used for two purposes. One purpose is what? If we are getting the very less amount of current also we can understand. And another thing, it shows the direction of the current. Okay, two way it is helpful. One is detecting the small amount of current, and otherwise in order to know the direction of the current. Galvanometer. And voltmeter is what?
Measures the potential.
Potential difference. Okay. EMF is nothing but the potential difference, you can say. Okay. So when this is the pattern of the to draw the circuit. So in the resistor we are connecting in series. In series now it should be connected like this. Okay. I am connecting three resistor. I am naming the resistor R1, R2, R3. Okay. I am giving the source. Current will flows from higher potential to the lower potential. Okay, so current flows in this manner. Okay, I told you whenever you draw the resistor, you have to draw the voltmeter here. Okay, in this condition now, current will be constant and the voltage will be variable. So how it will be variable? Na? It will be maximum in this point, and second maximum in this point, and third maximum, and this one is least. Understand? So in order to find the difference between this node and this node, we are connecting the voltmeter. Understand? So this is the process, main concept. Then the resistor are connected in parallel. Okay, I am connecting three resistor. I am naming it R1, R2, and R3. I am giving the source. Current flows in this manner. Okay. Whenever we are connecting the resistor, we have to connect the voltmeter parallel to it. Okay. In this concept, it is vice versa to this. The current will be variable, voltage is constant. You can give any example for these two things. Any example you can give. For give us an example for series.
Example for series circuit.
Yes. Series bulb, you know, like for decorating and all. In my house, Christmas time, na, we used to decorate Christmas tree with the series bulb. Color bulb will come up. It will be wider, tiny bulb. You will be there, na. Red color, blue color, they say. That is empty. Okay. If one bulb getting burst out or getting defected, damaged, na, then what is the use? You have to throw it out, isn't it? So then one bulb got diffused, it will corrupt the poorer circuit. Okay, so you can consider that as an example for series connection. Okay, then one component affected, na, it will corrupt poorer component. Okay, then what is for parallel connection?
Parallel connection, normal connection in the room.
House wiring system. See, all the things getting same voltage. Okay, so the fan also getting same voltage, tube light also, everything getting the same voltage. Okay, the current will be variable. Understand the concept? And imagine if I am connecting the source in the series, I am connecting the 5 bulb seriously. I am connecting. Okay, how the bulb glows?
First will be the brightest and then last will be the dimmest.
You say what you are thinking? In the series, I am connecting 5 bulb. Okay. So, how that bulb glows? Is that bulb will glow or not glow? So, it's nothing, you know answer, not knowing answer, it's same. You are sharing your knowledge. I am also sharing my knowledge. Okay? Then it's wrong also chatting up, no issues. What do you think? The bulb will glow, but the equally it will glow. Okay? All the bulbs will come. Okay. The bulb will glow, but same level. But if I'm getting more supply, I'm giving more supply, na, it will improve little more. Understand my concept? I'm giving. It's about it. It will be five bulb will glow the same. Okay, but dimmer. It may be dimmer according to my source. If I'm giving more source, it will glow. Thoda acha. More source I'm giving, it will grow brighter. Understand? But in series, whatever happened in one bulb, it same thing will happen at the last also. Okay, the parallel is not like that. If one is burst out, it never affect that. Okay. Oh, right. I teach you the formula, how we are getting that formula. Okay. So you understand this. Now we are going to derive the formula. Okay, what is variable in series? Voltage is variable now, so we are going to find the voltage. V equal to V1, V2, V3. I am connecting the resistor now. Solve that. Now the Ohm's law getting entered. Okay, I told you the Ohm's law is about the resistor, isn't it? So V equal to IR. Okay, we can find it for this now. So V1 is what? I is constant. Okay, so R1. V2 is what? I R2. V3 I R3. Okay, I am substituting these things in this formula. So I R equal to I R1 plus I R2 plus I R3. As this is constant, I am taking this out. I1 plus I2 plus R1 plus R2 plus R3. I R. And this I get cancelled. Okay, then formula would be R is what? R1, R2, R3. When the resistor connected in series. Okay, so we are connecting the resistor in series as well as the parallel. What is the first condition? In series, current would be constant. Okay, current is constant, voltage is variable. Okay, so already I told you whenever we are connecting the resistor, we have to connect the voltmeter parallel to it. So I am connecting in all the node. So I am getting 3 voltmeter. Okay, so I am find the value for the voltage. V equal to V1 plus V2 plus V3. Okay, I am implementing the Ohm's law here. V equal to IR. Okay, using that we are getting V1 is what? I R1, V2 I R2 like that. I am substituting that in the formula. I am getting this. I get cancelled, and formula for when the resistor connected in series. I am connecting 3 resistors, so R1 plus R2 plus R3. If I am connecting 5 resistor, R1 plus R2 plus R3 plus R4 plus R5. Understand? Now the resistor connected in parallel. I connected the 3 resistor here. Okay, and see the source I am getting what? Current flows from higher potential to the lower potential. This current when reaches here. After reaching this point, the current will be splitted. Current is getting divided. So I1, I2, I3. Okay. In 11th and 12th, you have to study how they are framing the resistors. And, you have to find the value of it. So understand, try to understand quickly. See, so it is splitted like in this way. So here we are going to study about the current. What? I1 plus I2 plus I3. Okay? Implement the Ohm's law, V equal to IR. In order to find I equal to V by R. Okay? We can find for I1, isn't it? I1 is what? V by R1. I2 is what? V by R2. I3 is what? V by R3. Okay? We are substituting in this formula V by R3. Why I am putting RT in a parallel resistor? Equal to V by R1 plus V by R2, V by R3. I told you this connection V is constant. Okay. So as a I'm taking as a common. So 1 by R1, 1 by R2, 1 by R3. Okay, this V and this V got cancelled. Therefore, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. I hope now you understand the formula how we are getting. Okay, this how we have to derive the formula. And sometimes they ask you derive the formula when the two resistors connected in series, four resistors connected in parallel. Okay, now you are able to get the formula, isn't it? It is easy. Okay, this is one pattern. Another thing, they give you the value like 2 ohm, 3 ohm, 4 ohm. Find the equivalent resistors. How will you find? Yes, because RS is what? 2 ohm plus 3 ohm plus 4 ohm. What will we get? 9 ohm. So they sometimes they give you the value and ask you to find the equivalent resistance. Okay, what about this? I am giving 1 ohm, 2 ohm, 3 ohm. So you have to substitute it here. 1 by Rp equal to 1 by 1 plus 1 by 2 plus 1 by 3. Find the LCM and find the Rp. Okay. It is in 1 by Rp. Then you have to find for Rp. Okay. Do the numericals and get the value of Rp. Okay. This is another pattern. Now you understand. Other concept we want to see is the heating effect of the current. Okay, already I told you when current passes more, the heat generates more. It's due to the flow of electrons. Okay, it will corrupt that circuit. This is like power is equal to V into I, voltage into current. You can substitute any formulas. Okay, volts also you can substitute. At last we will get I square R. Joule's law we can say as I square RT. H equal to I square RT. Okay. Then instead of V equal to IR, you can substitute I value also. So what will they get the formula? I square RT then is.
I did not understand the question.
So the heating effect of the current is we can say E equal to VI. This is a basic formula. Then we are substituting the Ohm's law in that formula. At last we are getting I square RT. In other form also we can get. Through the Ohm's law also. Well, you can implement the Ohm's law and get the other formula also. One heat effect of the current. V square. You brought a textbook with you. Okay. Shall we start again? Okay. The questions will from basic only. Okay. I want everyone to participate. How we can do? I can give you the paper, you solve and give me back, or shall we play like a quiz? It's चलेगा. Okay. Take a paper, upload anything. Try to solve and tell me.
You can't write. You can't write. I have to explain like.
It's a very simple only numericals. But for you people, I'm writing the formula also. You can use this formula. If anything comes in, I will tell you. While going, I give you the model answer as well as the question paper. Don't forget to read it.
Who? What's her name?
Yes.
Trisha, you can keep your name as okay. Like Trisha. Naina. Nandana किधर She's Nandana. No? आप Naina. Okay. Shall we start? If you have to say okay. SI unit of the electric current is SI unit of the electric current. Hmm. I told you today only. I told you today only. I thought, Mama.
So electric current you asked.
Thank you. I have taught now. Okay. Direction of the conventional current is current. How the current flows. Higher potential to the lower potential. The electrons will be vice versa to the current. A closed circuit means what? Continuously. Very good. 9. Which of the following is an insulator? I am telling the options: copper, silver, rubber, aluminum. Conductor copper. Okay, rubber. The silver is also a good conductor. Actually, compared to copper, silver is a अच्छा conductor. We can't afford it. इसके वजह से we are going with the copper. In something, we are circuit we are going with the nickel. Why we are going with the nickel? Due to the heat effect of the current. I told you when more current passes, it creates heat now. So when it passes now, so having high resistance, it protecting little current is what nichrome doing. Copper is allowing all the electrons, so it having the low resistance. Okay, resistance what? Resisting the flow of current. The copper allowing everything, so it having the low resistance. Compared to nichrome, copper having
low resistance.
low resistance. It passing current more. When current passes more, it creates the heat. Okay, in order to avoid that, we are choosing the nichrome. Okay. Then, which of the following is conductor? Wood, glass, plastic, iron. Iron is equal. Current is measured by
Instrument.
yes. Ammeter. Then shall we turn off the AC? Which is true about the open circuit? Bulb glows, switch is closed, no current flows, more current
No
flows.
color knows.
She told.
I don't first. I don't know first. I don't know.
Okay, I have both of them. I give you marks. The unit of the electric charge is what? 9. In a conductor, the flow of in a conductor, the flow of electrons will be
Low potential to high potential.
Okay, listen carefully. 10 coulomb of charge flows in 5 seconds. The current is 10 coulomb of charge flows in 5 seconds. The current is
2 amp.
solid. A current of 2 ampere flows for 3 seconds. The charge transferred is understand why she's saying 6. If 12 joule of work is done in moving 4 coulomb charge, the potential difference is what? Twelve joule of work is done in moving 4 coulomb charge. The potential difference is
3 volts.
I have to say it, Turan, she only got point. Or louder your voice. Then a charge of 60 coulomb flows through a conductor in 2 minutes. Understand? 2 minutes. The current is a charge of 60 coulomb flows through a conductor in 2 minutes. The current is a charge of 60 coulomb flows through a conductor in 2 minutes. The current is
0.5 amp.
9-volt battery transfers 18 coulomb of charge. Work done is a 9-volt battery transfers 18 coulomb of charge. Work done is work done. W equal to what? 9-volt battery, 18 coulomb.
162.
Means it? No. A unit of current expressed as coulomb per second is equal to today I thought a unit of current expressed as coulomb per second is equal to if it is wrong also Chalika you start speak. If a current of 0.5 ampere flows for 2 minutes, total charge passed is if a current of 0.5 ampere flows for 2 minutes, total charge passed is Nandana, Naina, understand? 50 coulomb of charge flows in 25 seconds. The current is
2.
very good, Nandana.
Chill.
Work done to move 10 coulomb of charge through 5-volt potential difference is
50.
Naina.
I told.
Oh, Nandana. Okay,
Yes.
super. A potential difference of 1 volt means what? The potential difference of 1 volt is determines what? Voltage is what? You can say the formula and explain that.
1 volt will be the work done in upon the coulomb.
So work done is what? Unit of the work is what? Joule.
You.
And charge is what?
Coulomb.
So charge is from? I am only saying. The potential difference of 1 volt means what? Okay, I am giving you answer. It's options. Tell me. Okay. Yeah, 1 coulomb of charge gains 1 joule of energy. Okay. 1 ampere of a current flows for 1 second. 1 coulomb of charge gains 10 joule of energy. Then 1 volt of power.
The first one. Can we get the first
one? 1 coulomb of charge gains 1 joule energy. Then 1 ampere of current flows for 1 second. 1 watt of power nahi hai.
First option.
She only told us.
I told before her.
No, she
I
told.
did. I did.
Then she told me to repeat also.
I said to repeat. I guess she told.
Okay, I am giving you a mark for that. Okay, symbol of the cell is how it looks. It looks like a O or 2 parallel lines. One is long, another one is short. A cell, yes, cell.
Oh, cell.
Yes. It looks like a O, okay? Or else it looks like a 2 parallel lines. One is long, one is short, and zigzag line, circle with cross. How it looks? The symbol would be second. Yes, I'm giving out to everyone. Okay, a symbol of battery is what? I'm giving you example. Options: a key, zigzag line, circle with dot, multiple cell joint.
Multiple cell joints.
Okay, I'm giving you. Galvanometer is used to measure resistance, detect current, measure power, store charge. Vandana. Ammeter is always connected in parallel in series across a resistor, across a cell. Ammeter is always connected in parallel in series across a resistor and across a cell. Series. She told answer. Actually, it is series. Connected in series. The voltmeter should connect a parallel. Okay. Okay. A switch is used to increase resistance, open or close circuit, provide potential difference, measure current. Nandana. A symbol circle with the letter A inside represents what?
Ampere.
Oh.
No. A circle with a letter inside. Any letter with letter
A.
A. Ampere.
They know, but they are confused. Ampere is a unit of the current. Okay. Ammeter is an instrument. Okay. Ampere is what?
Unit.
Unit of the current. Okay. Ammeter is what? Measure. It's an instrument measuring the current. Ammeter alage, ampere alage. Okay. They understand. They are confusing. So, whom I should provide mark? She only told exactly, but you people understand, but you can't convey that answer. I can understand. I'm giving mark to her. Okay, listen carefully. It's a symbol circle with a letter V. V.
Voltage.
Instrument.
I know.
Actually, Trisha know the answer, but she was allowing you people to talk. You people to. Actually, I like your character. Achha, very good.
I know it. I don't know.
Right. It's an instrument. Okay, what is for current?
Current.
Current instrument.
Ammeter.
Ammeter na. Meter na.
Voltmeter.
Voltmeter. Okay. Voltmeter. Voltmeter is used to measure the voltage. Ammeter is used to measure the current. Meterage, okay, it is an instrument. Whom I should give? Nandana, Naina.
I told no, so I get the mark.
Naina. Okay, which is the source of the direct current? I am telling you the options: cell, battery, accumulator, all of these. Direct source, direct current.
Always.
Well, Nandana. Which of the following is not a DC source? Cell, battery, accumulator, AC generator.
AC generator.
Okay, for everyone. Okay, I'm not giving. Yes. An accumulator stores what? Which energy? Accumulator is what? It's a chemical energy. Okay, it's a chemical one. Then only we can use it whenever necessary. We can charge it also. It's a chemical energy. And which device produce the alternating current? Cell, battery, DC generator, AC generator.
What did we ask this question?
No, that one is which is not the DC source. This one is which device produce the alternating current? Which device produce the AC current? AC is what? Alternating current. DC is direct current. The difference between that now, DC is like only flowing. So AC we can give for a long distance. DC for short distance. Okay. For all the component we using the DC. Okay. Then AC is what? For house wiring system, transferring the one source from other. Okay. That is DC. So that is AC. Okay. Step up, step down, everything we're doing by the AC. Okay. How we are mainly generating the AC? AC, how we are generating? I am telling everything. Cell, battery, DC generator, AC generator. Yes. Cell is a DC one. How can it generate AC? I am itself telling the answer. I am itself putting the mark for it. I am trying. I am saying everything. Okay. A car battery is an example of what? Primary battery, secondary battery, fuel cell, solar cell. Car battery is an example of what?
Fuel.
You tell all the options. Primary, secondary, fuel, solar. Battery, car battery. You are putting fuel to the car, not to the battery.
Secondary.
Secondary, Nandana. Why it is secondary? It is it is rechargeable. Okay, rechargeable is a secondary cell. Okay. Which one is rechargeable? Dry cell, accumulator, mercury cell, solar cell. Solar cell na we can use directly also. Which one? Dry cell, accumulator, mercury cell, solar cell. Accumulator. 9 enough. A group of cell is okay. In torch, the source of current is what? In torch, the source of current is none.
I told cell.
Oh, you told 9. two identical bulb is in parallel connection get what? Two identical bulb connected in parallel connection get what? You see this diagram. Instead of resistor, you can keep bulb.
Equal amount of current.
In parallel connection. The parallel connection you are saying. What is the key point of it? When the resistor connected in parallel, what is the key point? I have told it many times. When it is connected in series, now same current will flow from one point to other. Okay, but the voltage will be different. Okay, it's not about the resistor. You can take any load. If you connect any bulb instead of resistor, so same current will flow in this way, but the voltage will be different in each and every point. If you take here in the bulb now, same current will flow until this point. After reaching here, it will split. The current will be variable, so voltage is constant. Okay. Now answer. Two identical bulbs in parallel get what?
Different currents but same voltage.
Okay. A bulb in if a bulb in parallel blows out, what will happen?
Well, the others will function.
Others will function. If a bulb in series blows out,
Other loads.
no. A fuse in a circuit is connected in
What?
circuit is connected in series. Who said?
I also said same thing.
Rishabh. Electric current produces what? Heat, magnetic effect, chemical effect, all of these. This that branch also I have noticed. When all of these options come in, you people they are telling that all of this.
Heat, electrical.
No, you have to know all of these questions. A device is to vary the resistance in a circuit is called what? A device is used to vary the resistance. You know, Trisha?
Rheostat.
Rheostat. Actually, it is a device. How we see the resistor? Resistor having the particular name for this resistor is this value, this resistor is this value, we can identify, isn't it? But imagine in my project, I need a 27 kilo ohm, but मेरे पास नहीं है. Then what I do? I take the rheostat. I can assign to the 27 kilo ohm, and I can use more. If I want दूसरा value also, I can use it and then adjust the value and keep it for that. Okay, we can vary the resistor is called rheostat. So it looks, it's a component. It looks like this. So it's T. Okay, rheostat. The energy given to each coulomb of charge by the battery is what? The energy given to each coulomb of charge by the battery is what? Coulomb. Charge. The energy given to each coulomb of charge by a battery. Shall I tell you the options? Resistance, current, potential difference, work function. Potential difference. The instrument used to detect a very small amount of current is what? Galvanometer. galvanometer. G-A-L-V-A-N van.
GL,
G-A-L-V-A-N van. O meter. Galvanometer. Okay, now I am going to ask you the how the circuit connection. Okay, a circuit diagram has two bulbs in series with a cell. The current in both bulbs is what? A circuit diagram has two bulbs in series with a cell. The current in both bulbs is same. 9. Two identical bulbs are connected in parallel with a battery. Which one is correct? Okay, I'm saying with options. Each bulb gets half of the voltage. Each bulb gets full voltage. Voltage divides equally. One bulb gets more voltage. Two identical bulbs are connected in parallel with a battery. Okay. Which one is correct? Each bulb get half of the voltage. Each bulb get full voltage. A voltage divides equally. One bulb get more voltage. So you need all that, na?
First option.
And you are saying each bulb get half of the voltage. You see here. See the diagram.
But gets full voltage.
Yes. I told you what I told you. See, in parallel connection, everything gets the same voltage. In housing wire also, I told you, now this fan will get the same voltage as the light gets. Full voltage. Whatever the voltage coming, it will give. Okay. A student connects 3-volt battery, switch bulb in series. If the battery is closed, the bulb will. A student connects 3-volt battery switch bulb in series. If the switch is closed, the bulb will turn on. Nandana. Okay. A circuit has two cells of 1.5 volt, each in series with a bulb. Okay. The total potential difference is what? A circuit has two cells of 1.5 volt, each in series with a bulb. Understand why we are getting 3 volt? Series. So 2 times 2 source 1.5 plus 1.5 3 volt. In a circuit, two bulbs connected in parallel. If one bulb fuses,
The other will contribute to the
9. Okay. In series circuit of two bulbs, if one bulb fuses, series fuse 9. Which arrangement will make the bulb glow brighter? One cell in series with bulb, two cell in series with bulb, two cell in parallel with bulb, no cell connected. One cell in series with bulb, you are saying, or two cell in series with bulb. One cell, you are saying. Two cell in series. The ammeter connected wrongly in parallel with the bulb. It will. It won't read also. Sometimes it will get damaged. Okay. A student connects 6-volt battery with a bulb and close the switch. If the bulb doesn't glow, possible reason, what will be the possible reason?
Student connect.
A student connects 6-volt battery with a bulb.
The battery might be.
You can close.
The battery might be.
Battery may be dead. Okay, then what are the reason?
The switch is closed.
Yes, when the switch is closed, it is in question itself.
The switch may be.
Bulb is maybe fused. Okay, and connection may be wrong. Okay, these are the three possible reasons. Okay, and now you have to understand the question. In a circuit, voltmeter connected, a bulb shows 0 volt even though switch is closed. Because of what? Voltmeter giving 0 volt. If voltmeter giving 0 volt now, then in closed circuit only, if giving the 0 volt. What would be the reason?
The battery might not be working.
No, battery is working only. Shall I give you the options? Ammeter fault, bulb fuse, extra cell connected, switch open. Bulb fuse, London. If 3 bulbs are connected in parallel to the cell, the brightness of each cell is same as single bulb, dimmer than single bulb, unequal, one glows, other don't. 3 bulbs are connected in parallel to the cell. The brightness of each cell is
Options.
same as single bulb, dimmer than single bulb, unequal, one glows, other don't.
Unequal.
Unequal, you are saying? Okay. If 3 bulbs are connected parallel to the cell, okay, the brightness of each cell is how will it be?
It would glow dimmer than a single bulb.
As single bulb. Actually, now see the series connection or parallel connection. If one bulb glows kitna hai, same thing other till end it will glow. Okay, same, no changes. But it's brighter or dimmer according to the series or parallel. Series now, sometimes according to the source it will glow. If you're giving less source, it will dimmer it will glow. More source if you give, brighter it will glow. Parallel is in it. Okay. So because a parallel culture is it will get same voltage. Okay. So these 3 bulbs are getting connected in parallel to the cell. Brightness of each cell is same as single bulb, dimmer than single bulb, unequal, one glows, other don't.
Same as single bulb.
Same as single bulb. Okay. Who's yes, okay. A student uses copper wire instead of nichrome wire in a circuit because of what?
Because it has more conductivity.
Hmm?
More conductivity.
More conductivity. Okay. Then you can tell the feature of the copper, isn't it? What is the feature of the copper? What is the feature of the copper?
It has less resistance.
Yes. Then
It produces less heat when the current is flowing.
it creating heat. Okay. So high current flows. Okay, this is the reason. Understand? So it will come under the heating effect of the current. The specific resistance of the wire depends on
The nature of the material.
nature of the material of the wire. Okay. Ampere hour is a unit of what? Hour. Ampere hour. Let's show you. Okay. The strength of the current, power, quantity of the electricity, energy.
The first option.
Current. Ampere is current. Ampere hour. Strength of the current, power, quantity of the electricity, energy.
Quantity of the.
See, it's like we are using this much battery for see every day ka advertisement dekha 12 hours power like that. We can take that as an example. This much time only we can utilize this much source. Okay, say so ampere hour. Okay, the flow of current we will get for this much amount of time. Okay. Insulator have dash temperature coefficient of the resistance. Tell me, insulator have dash temperature coefficient of the current. Take one. Okay. One answer and have you taken the model answer also? Here you have the advanced level of questions. Okay, just go through once. Maybe the model answers may be wrong. Okay, I didn't check the model answer. I just have to check the questions only. You may get question like combination of resistor. They ask you to find the equivalent resistance. So if you find difficult now, you have to take a photo and put it in the WhatsApp doubt solving. I will solve and chat because we don't have time to solve here. I didn't check the model answer, so I'm asking you to just go through this level of questions. Last week, who win the game section? Go and take water. Take the pen. Very good. Today, Krisha only got 27 points, Nandana got 16 points, Naina got 14 points. Okay? Next time, improve. Okay? Krisha, this is for you.
I actually had a doubt in this question. How do we solve this?
See, resistance and capacitance is vice versa. Okay? If the resistors are connected in series, plus will be there now. So, when capacitors are connected in series, parallel 1 by C equal to 1 by C1 plus 1 by C2. Say you have to draw. You have to find in that manner. That formula you have to implement. Okay? That is the formula. It's vice versa. Capacitors used to store the charges. Okay, just go through once. You have any doubt?
What is a potentiometer arrangement? Elasticity.
Potentiometer is like a tuning. For example, radio now, we can adjust the frequency now. For that, in my project also I use potentiometer. Potentiometer is like it's an instrument like we are adjusting, tuning the frequency. That is a potentiometer. Okay. What's the ambition, Krisha? After 12th, what you will do?
Probably engineering, science.
Okay. In this and all, you have to see network, R2 R network, like that you will get. Engineering first ED will be there, okay, electronics devices. In that first thing you have to study when this series is connected in series and parallel. Okay, they will give you many combination of the resistors. Okay, so it is very complicated to split the resistors also. I say they will ask you many questions. You have to understand how it is connected, parallel or series. Okay, then you can see in this manner you can understand it is series of parallel. But when the combination of a resistor happening, it is mushkil to understand that, isn't it? For example, if one ground is connected, another resistor is connected, and another thing is goes to the ground, you have to consider that as a parallel. Okay, then you have to little minimize the circuit. At last, you have to then it will come in this manner only. Okay, so you have to by seeing the circuit, you have to go with the make it minimize. You have to know how to redraw the circuit by simplifying that. First, you can go the parallel things now. You can put the formula and make it series. Then in series now, then extra you can add together, isn't it? So that will be. Then capacitor and resistor will be, you will get confused. Capacitor and resistor is vice versa. Think it in your mind. If it is plus now, then 1 by R1, or 1 by C1 capacitor. Okay. So when it is parallel, that will be series manner. Plus 1 C1 plus C2 plus C3. Like that. So, okay. So then in engineering is a combination of capacitor and resistors also will be there. Okay. So you have to understand the basic voltage and Wheatstone bridge and all you will study in the 11th standard. I hope so. So you have to go with that. And EC1 paper is there. Okay. It's a really tough paper. And EC2 will be very easy. Okay. Electronic circuits. There is a two papers in electronic circuits. First one will be very toughest because it is more depth. It is about the circuit connections. Fully consists of the resistors, capacitors. It's more complicated paper, and but it is very needed for the electronic engineering. So it is very tough, but you can clear. Then EC2 is nothing compared to E1. Okay, that much easy. And maths paper, SEM 1 will be tougher. SEM 2 it is easy, and after that you will get clear. So in first year, what are things you have to go through? ED is there. It is very simple as this physics, and maths and EC1. EC1 you will get in second year or third year. No, EC second year. EC1 paper you will get in second year.
JEE, is this important for starting?
Of course, of course. No options. JEE, you have to go with the CBSE pattern. But ICSE, you people studying advanced then there. See, you people now you know in Mira you are studying 9th standard, Lens you are studying in 10th standard. In they people now they will study both in 10th standard. Just imagine their condition. But the questions mostly will from their pattern only. So will be easy for you. ICSE board are going more advanced. They are making the question papers very tough. We can't predict also. Any other doubt? Okay. You have any doubt in physics? Any chapter?
We're taking the lab class for Sunday.
Okay.
Work and energy.
Work and energy power. That one?
Yeah.
Okay. That 15 minutes class.
Yeah.
Risha, you have any doubt? Okay. shall we go? Try to finish these assignment by this week, okay?